example number 5 out of the textbook is they want us to find this. And I'm not even going to tell you what this is. Actually, they wrote it a little different. It's not f of x. It's 8 equals this. Okay? Now what that is some crazy stuff. And they want a second derivative. Y double prime is basically what they want. So we need to differentiate this twice. So now to differentiate this twice, we have to do it implicitly because y is raised to a power other than 1. And so we still want to find dy dx. So what we do is we say dx ddx of 8 equals 2x to the third minus 3y squared. Dx of 8 is 0 equals, the derivative of this is 6x. Minus 6y. Now, whenever we have any term that has anything other than x, we have to write d, whatever that variable is, over dx. So, in other words, I have to tack on that dy dx.
3 times, isn't it 6x squared?
Oh, yeah, it's 6x squared. All right. So now to differentiate that implicitly, I got to solve for this dy dx. So I move this over to the other side, and I get negative 6x squared is equal to negative 6y dy dx. Divide both sides by negative 6. These cancel, and I get x squared is equal to y dy dx. And then we divide both sides by y. And so I get x squared over y is dy dx. And so that's the first derivative. So I'm going to start fresh over here, and I'm going to say y prime then is dy dx, which is equal to x squared over y. Well, we wanted y double prime. So now to find y double prime, I just have to take the derivative of this. And so to take the derivative of this, what I need to do is I need to think of it like this. Right? And so what I want to think in my head is u over v prime. Well, that's the quotient rule, right? So then u is equal to x squared. U prime would be 2x, and v then would be y, and then v prime would be 1. But remember, we've got to say 1 dy dx. And you'll say, well, I don't know, that doesn't make any sense. Now you could write it this way, or you could write y prime. We'll leave it this way for now. I know your textbook has it the other way. So then, if that's the case, to find y double prime, which is really dy, this thing here, which is what they were asking, then I will plug that into the formula. And now remember, the formula for this is going to be u prime v, or vu prime, minus v prime u all over v prime, or v squared. Right? And so what I have is I'll end up having 2xy minus x squared dy dx all over v squared, which is y. And so the only problem with that is, guess what? I don't have it in terms of x and y. I need to address this. How do I make that in terms of x and y?
Can you multiply by y squared and then cancel that out?
No, the answer is this. dy dx is equal to x squared over y. So what I need to do is I need to say that this is equal to 2xy minus x squared. Then in parentheses put x squared over y all over y squared. Does that make sense?
Mm-hmm.
And I suppose we could clean that up a little bit. There are a bunch of y's in there, so let's see what we could do to clean this up a little bit. I'm going to separate it and see if that makes it any better. So in other words, what I'm going to do is I'm going to say 2xy over y squared minus x squared times x squared all over y squared, and then this y comes down on the bottom. Does that make sense? And so then,
Why don't the why?
well, think of it like this. What I'm doing is I'm going to say negative x squared y squared, right? And so that's this right here. And then what else am I multiplying that by? Well, I'm going to multiply that by this. Yeah. Does that make sense? Okay. So then if I clean that up, this y cancels one of these y's. So I got 2x over y minus x to the fourth y cubed. Now you could clean that up maybe and put it under one as one term. That could be 2x y squared minus x to the fourth all over y cubed. And you might say, Mr. Adams, how did you do that? Well, if I multiply this by y squared and multiply this by y squared, that gives me the common denominator of y cubed. You guys see that?
Yes.
Okay. And that is it. Does that make sense?
Yep.